Hello students, welcome to Narayan online classes. So in the last video we have discussed about the dipole moment and its applications. Clear? So here some portion, small portion is left here. So what is that one very important question? This is for the PU examination. Clear? So comparison of dipole moment of NH3 and NF3. Clear? So we have to compare dipole moment of NH3 and NF3 and which molecule has the high dipole moment, that we have to identify. Clear? So now if I draw the structure of this NH3 and NF3, both have the same structure, that is the pyramidal structure. Clear? So nitrogen, you know that whenever nitrogen forms three bonds, covalent bonds, then it will have one lone pair of electron, because you know nitrogen electronic configuration is NS2 NP3. Three unpaired electrons will participate in the bond formation, three bonds, and one in the S2 and the 2S2, one paired electron will be there, that is act as a lone pair. Clear? So if I write here NH3, both will have the pyramidal structure only. Clear? Here there will be a lone pair. Clear? So NF3 if I write same structure, here also pyramidal structure only. NF, and here what? There will be a lone pair. And what generally we will think, and here fluorine is more electronegative than the nitrogen, so that's why you know in this case fluorine is a highly electronegative atom, so that's why we will think this bond is more polar. If it is a more polar, then it should have the more dipole moment. Clear? So I said that is only applicable most of the time for the what it is here, diatomic molecules only. Some cases we can use that concept, but not all cases. Clear? So that's why you may think the electronegativity difference between the nitrogen and fluorine is maximum, so that's why these bonds are too polar. If bonds are too polar, much polar, then automatically you know Q will be, means charge will be highest. If charge will be highest, automatically we can say dipole moment also increases. Clear? But the concept here, if you apply that concept, and you will get the wrong answer in this case. Clear? So why means first of all we will see. Yeah, you know that this is a lone pair of electron. You know the dipole moment direction of lone pair is always upwards, and here also what is dipole moment of this pair of electron is also always upwards. Clear? Now you see in this case nitrogen and hydrogen, which one is more electronegative? Nitrogen. So that's why the dipole moment direction for this bond is towards more electronegative atom, and here also towards more electronegative atom, that is what it is here, nitrogen, and here also towards more electronegative atom, nitrogen. Clear? See now, this direction of these three bonds are towards nitrogen. What is the resultant? You have to see, I already mentioned, for polyatomic molecule, you should not consider the dipole moment of the single bond. You have to consider the net or resultant dipole moment of individual bonds. That is important. Clear? So that's why these three bonds and resultant dipole moment you have to see. This is one is coming, this is all are coming like this. Clear? So what will be the resultant dipole moment? Upward. That is the resultant dipole. Clear? Already, you know, and resultant dipole moment is in this direction. Already, and you know, lone pair dipole moment is upward. So what will happen? Already dipole moment is towards upward, and here will be added, so that's why it will have the more dipole moment, and that dipole moment value here is almost 1.47 TeV. 1.47 TeV. This is the dipole moment. If you calculate, you will get this answer. Clear? 1.4. This is experimentally calculated value. What is that one? 1.47 TeV. Coming for this compound NF3. See in this case what happened? Nitrogen and fluorine. Nitrogen and fluorine means which one is more electronegative? Nitrogen. So dipole moment direction of this individual bond is towards nitrogen. So here also what it is? Towards nitrogen, because nitrogen and fluorine is most electronegative, more electronegative than the nitrogen. So that's why dipole moment direction will be here. So now we have to see the resultant of this. If you see, this is the dipole moments. Clear? No? So one is here and one is here. So what should be the resultant dipole moment? The resultant dipole moment is like this. This is the resultant dipole moment. Or simply, if I write in this case, see that is, this is the dipole moment of one, and this is second, and this is third. What should be the resultant dipole moment? In this direction. This is the resultant dipole moment. Means, in this case, the resultant dipole moment is downwards. And here, the lone pair, here nitrogen and lone pair is there, the lone pair dipole moment is upward. Then what will happen? Some of the dipole moment will be cancelled. Will the dipole moment is 0 here? No, it won't. Why? When it will be 0, suppose if here another fluorine is there, and here that dipole moment of all this fluorine is this, and that dipole moment of this fluorine is upward and it is downward, so opposite direction magnitude will be same and dipole moment will be 0. But here there is no fluorine. Here what it is, man? The dipole moment of this is lone pair of electron, this is net dipole moment of fluorine. Both are in opposite direction, but not magnitude is not same. If both atoms are same here, then automatically the magnitude also same. Clear? So here dipole moment will not be 0, but dipole moment is cancelled out. So that's why what you will get here, you will get some value. That value is 0.24 D. Clear? So here dipole moments are added and here dipole moments are cancelled. So that's why what will happen here? The dipole moment of NH3 is greater than the dipole moment of NF3. Clear? So this is about the comparison of dipole moment of NH3 and NF3. So they are asking this question in the PU examination. Clear? So in the NCERT textbook they have given one table for the dipole moment and the dipole moment of selected molecules, and I will draw that one and you also draw that table in your notebook. Clear? First one is type of molecule, Clear? Next one is example, dipole moment, that is I will write symbol here, mu, and geometry. Clear? So geometry. Here they have given four terms. So you have to draw the table here. Clear? First one is molecule, AB type molecule. Means what it is, man? AB means only diatomic molecules. Diatomic molecules, example if I take HF, HCl, HBr. Clear? If I take iodine or H2, whatever it may be, you can take H2. Dipole moment. Clear? Diatomic molecule, you know, diatomic molecule dipole moment is depends upon the difference in the electronegativity. Clear? Greater the electronegativity, greater will be the dipole moment. HF will have the highest dipole moment. What is the value they have given? I am writing in the divide. They have given these values in the divide. 1.78 for HF. Sorry, 1.78, and here for HCl 1.07 divide, and HBr I have not written here. So HBr and HBr and what is here? Hi and H2. HBr means they have given 0.79 and 0.38. For hydrogen, what is the dipole moment? 0. These all molecules will have the linear geometry. All molecules will have what geometry here? Linear geometry. See, just I want to say, I have given already. H of here, H of HCl, HBr and diatomic molecule is there. You have to see that. Here common is what? Hydrogen. See the electronegativity of the second atom. And here fluorine, bromine and iodine. As electronegativity increases, dipole moment increases. Fluorine is the most electronegative element atom, so that's why for that one will have the highest dipole moment. For HF to HI, dipole moment will keep on decreasing. H2, why dipole moment is 0? I already mentioned why H2 dipole moment is 0. H2 is a non-polar molecule. This is H and H. Both are same atom, so that's why this pair of electrons will not move towards any of the atoms, so that's why poles will not be. If these bond pair electrons shifted to any one of the atom, then if shifted to one atom, then it will be positive and it will be negative. But both are same atoms only, so that's why the bond pair electrons, these two electrons lie between the two central atom and poles will not be generated. If poles are not generated, charge will be 0. Charge is 0 means dipole moment will be be 0 because dipole moment U is equal to Q into D. Charge into distance, charge is 0. That we have already discussed. And second one is AB2 they have given. AB2 type molecule. Central atom is A and surrounding atoms are B. Clear? Further one, examples they have given. One is H2O and the another one is H2 gas. And third one is CO2. Dipole moment you see here. Dipole moment is 1.85, 0.95, and here CO2 is there. CO2, what is the dipole moment? 0. I already mentioned CO2 dipole moment because this is the C double bond O. This is C double bond O. This CO dipole moment direction is in this one, and this is both are opposite direction and to the same magnitude. Because here also oxygen, here also oxygen. And how much dipole moment value will be there, and that much dipole moment value also will be there here. But the directions are, if it is positive 1D, then it is negative 1D. So that's why what is that will be 0. So that's why 0. Clear? In the same way, molecule. If you take molecule here, this is what is the shape means for these two bed shape. We will discuss later what are the shapes of this molecule. This is a linear. CO2 is a shape here, linear. Next one is AB3 type molecule. Clear? AB3 type molecule. So if you take AB3 type molecule, NH3, and the next one is NF3 and boron type molecule. Clear? See now. Here NF3 just now only I have discussed 1.47 and 0.24 and it will be 0. Both are all are here. What it is? These two are pyramidal shape. This is what shape here. Pyramidal shape. And here also second one also pyramidal shape, but this is trigonal planar. This is what it is here. Trigonal planar shape. Trigonal planar shape. Last one is AB4. What is the molecule? What is the central atom is A and surrounding atoms are 4. B. How many are there? 4. So they have given here CH4, CHCl3, and last one is CCl4. So what is the value here? CH4 will be 0 and CCl4 will be, CHO4 will be, CHCl3 will be 1.04 and 0. And here all are tetrahedral only. All are what it is not here? Tetrahedral. This is the table in the answer textbook they have given. Simple you see. First one I have explained, then AB2. Clear? If you take in this one, there will be a lone pair on the sulfur here central atom. But carbon doesn't have the lone pair. Carbon doesn't have the lone pair and the oxygen atoms are there. Then what it is? Only bond pairs are there. Only bond pairs are there. It is a geometry will be a, we will call it is a regular geometry or molecule is a symmetry. Symmetry molecule or molecule having the regular geometry. Then dipole moment will be what is 0. So that's why for this one dipole moment will be 0. But this dipole moment will not be 0. Why it will not be 0? Because these molecules along with the bond pairs, lone pairs also there, and these molecules are not symmetrical or they don't have the regular geometry. If they don't have the regular geometry, they will have some dipole moment, and that is clear. Here also NH3 is having lone pair and NF3 is also having lone pair, but boron BF3 is not having any lone pair here. Any lone pair means what is it? It is a regular geometry. Regular geometry means what will be the dipole moment? 0. CH4 is carbon is having any lone pair? No, carbon not having any lone pair. Why? Because what is the carbon electronic configuration? NS2, N32. Here how many electrons? 2 electrons are there. And here how many electrons are there? 2 electrons. But in the first excited state, one of the electrons will move into the p orbital. How many unpaired electrons are there? 4. Is there any lone pair? All 4 are participating in the bond formation. So carbon forms 4 bonds. After forming 4 bonds, is there any lone pair of electrons here? No. So that's why it doesn't have the lone pair, and also all the surrounding atoms are same. I already mentioned, if central atom is not having lone pair and all surrounded atoms are same, then that dipole moment will be, for that molecule dipole moment will be 0. Clear? So I have already mentioned. CHCl3. This one also, carbon is not having any lone pair. You don't think that it is a regular geometry or molecule is a symmetrical. Why? And I already mentioned the condition. What is the regular geometry or symmetry means? And central atom, first one, should not have any lone pair of electron, or the central, another point, the central atom should attach to the surrounding atom. All the surrounding atoms must be same. Then only it will have the regular geometry, or you can simply say molecule is a symmetrical. Here it is having geometry. What it is lone pair of electron doesn't have. Don't think that it is having regular geometry. It is regular geometry, but you don't think that it is a symmetrical molecule. Why? Because you know here hydrogen is having and 3 chlorine. All the central means surrounding atoms are not same. So that's why it will have some dipole moment. But here you see central atom not having CCl4. In the CCl4, central atom is not having any means lone pair of electrons, but all surrounding atoms are same. So that's why molecule is a symmetrical, or it will have the regular geometry. So that's why what it is, it will have 0 dipole. Clear? So these are the conditions we have already discussed, and this is about the what it is here, dipole moment, and a very very important concept. So next one is limitation of Lewis concept of covalent bond. Till now what we have discussed, formation of covalent bond, formation of dative bond. So all we have discussed considering the Lewis dot structure. Isn't it? Covalent bond, how it will form means, I already mentioned one atom give one electron, another atom give another electron, and that they share in order to complete octet. And we have written that Lewis dot structure. The bond pair electron, the electrons, 2 electrons between the 2 atoms belongs to both the atoms. We have drawn the Lewis dot structures for all. In dative bond also we have written Lewis dot structure. Clear? So Lewis dot structure or Lewis concept has some limitations. Clear? What are those limitations? Clear? So every time when we are writing the Lewis dot structure, I already previously mentioned, and we are keeping the central atom. First we will keep the central atom, and around the central atom we will put the surrounding atoms in our own way. We don't know where we have to put, and surrounding we are putting. We will put the atom surrounding. Clear? So it is not actually, if you write like this, you will not get the exactly shape or geometry of the molecule. Clear? So it failed to explain the shape of the molecule. Suppose simple example, I may write ozone, I will take. Clear? Ozone means what is O3. O3 means we have written like this. Sometimes I may write this. If you write like this, I will get one shape, bend shape, inverted V shape I get. Instead of that, I will write like this. Then I will get the linear shape. Clear? So which one is the correct? That is just we are writing skeletal structure. But exact means by using Lewis dot structure we cannot say exactly what is the shape of the molecule. Clear? So that is the what it is main limitation of what it is here Lewis concept. We are just writing skeletal structure. That skeletal structure may not give the exact shape of the molecule. And second one, and we already mentioned. So atoms they combine it together and to form the compound by forming bonds. Clear? But during that process, energy will be released. Clear? Isn't it? Atoms, I already said, atoms always have the high energy. When they combine and form the compound is stable compared to the atoms. And during that process, you know, A is there, atom A and atom B. These atoms are there. Atoms will have what it is not? High energy. Atoms will have high energy. Clear? When they combine, they should form what it is not? AB, and it is a what it is not? AB means, you know, this is a compound. Compound means what it is not? Less energy. Why the compound is less energy? Because during the formation of bond, both will get the what it is not? Octet. They form bonds in order to complete octet. While complete octet, you know, they are get stable. When they are stable, then energy will be less. And how molecule, high energy molecule will be converted into less energy molecule? This sum of energy it will be released, and they are converted into less energy molecule. So, and it could not explain the release of energy during the formation of covalent bond. How much energy is released? during the formation of suppose hydrogen atom, and they form H2 molecule. During the process, how much energy is released, and another O2 and oxygen, how much energy is released when a O2 molecule is formed, and could it explain? Clear? So to overcome these limitations, another one theory has been introduced, and that theory is what it is here, valence shell electron pair repulsion theory. Previous one, first class I mentioned, we have 4 theories in this chapter. First one, Lewis quotient theory, and second one is VESEPR theory. Next one is VBT theory, valence bond theory, and next one is molecular orbital theory. Clear? First one till now we have completed, and second one valence shell electron pair theory. Clear? First of all, I will explain, and after that I will write the points here. What is that? Clear? And first of all, this theory was introduced by and 2 scientists. One is Sedgwick and another one is Powell. Clear? Sedgwick and another scientist what is here, Powell. And these 2 scientists introduced this theory. Clear? And this was developed by another 2 scientists, Nyhol, and another one is Gillespie. And these 2 scientists developed this theory. Clear? So as I mentioned here, and Lewis concept, and do not explain the shape of the molecule. Clear? The simple theory introduced or put forward to explain the shape of the molecule. The first simple theory we can say. The first simple theory that put forward to explain the shape of the molecule is valence shell electron pair repulsion theory. Clear? So mainly this theory is used to determine the shape of the molecule. That is first point you have to remember. Clear? Now, so how molecule gets shape? Clear? And that he has given one simple theory. Clear? What is that one? You see, you know that the central atom is linked to the other surrounding atoms by a covalent bonds. You already know that. Suppose if I say A is there and B, these are what it is one. Clear? And AB3 I will write here. AB3 means what it means? Central atom is A and the surrounding atoms are which one? B. So they are linked to the central atom by a covalent bond. Covalent bond means what it is here? Covalent. Suppose NH3 if I take NH3, how we have written the shape? Nitrogen, hydrogen, hydrogen and hydrogen. It will have what is one pair of electrons. So in this one, the central atom is surrounded by bond pair of electrons. Pair of electrons means what? It is a one covalent bond means what is one? 2 electrons. It is one bond means how many electrons? 2 electrons. So central atom is surrounded by the bond pair electrons. In some cases, lone pair electrons also along with the bond pair. Here bond pair electrons are there, and here also what is one? Lone pair of electrons. That means central atom is surrounded by. Means simply I can write this is a and here. Clear? Yeah. This is bond pair. Sometimes it will have the lone pair also. Lone pair means non-bonding electrons which are not participated in the bond formation. Clear? So that's why these are, that means I will write here B and B and B here one lone pair is there. Clear? Means the central atom is surrounded by the pair of electrons. Pair of electrons. Those are bond pair electrons and can also be a lone pair electrons. You know that if the electrons are there around the central atom, electrons are which charge it will have one? Negative charge. Negative charge means what? They will, same charges will repel each other. So that's why here there will be some repulsions among the pair of electrons. When repulsions are more, energy will be very high. If energy will be very high, and stability will be very low. Clear? So that's why, and here due to the electron pairs around the central atom, and the molecule has much very high energy. Very high energy means the stability will decreases. Clear? So in order to minimize that energy, these bond pair electrons are this pair of electrons. they move away from each other till they experience the minimum repulsions. Till they experience the what is my here? Minimum repulsions, they move away from each other from the central atom. Clear? And they occupy the position in the space, defined position in the space. Clear? So that energy of the molecule minimize, and then it gives the definite shape of the molecule. Clear? So just now I have mentioned here, A is there and electrons around the A, electrons are there on the A, one lone pair is there. So when they are very close to each other, what will happen here? They repel each other high. So that's why what they will do, to minimize the repulsion, they move in a different directions. Clear? So if it is there A and one is move like this, another is move like this, another is move like this. So that's why what will happen? So they are moved away from each other, then repulsions will be very less. So molecule will get stability. Now if you connect this, you are getting one shape, and that is the shape of the molecule. Clear? So that is the main and what is how molecules have the definite shape or geometry means. This is the main reason that was given by what is my Sedgwick and clear? And another important means, what does it mean? Simple, to minimize the energy and the pair of electrons, they move in a different direction in a space. And if you join that, then you will get the what is the shape of the molecule. And how they will go means, suppose if it is there, lone pair of electron is there. Here there is no lone pair of electron, simply they are moving like this. Here lone pair of electron is there, and sometimes what happens, these bonds are there and they will move in this way. If they move in this way, they will have the minimum repulsions. Then you will get here pyramidal shape. This is what shape here? Pyramidal shape. If the electron, if one lone pair is there, the bond pair electrons, they move in a different pyramid, means in this direction, they will experience the very less energy. So that's why hydrogen will come. These bond pair electrons are here, and these bond pair electrons are here, and these bond pair electrons are here. This is lone pair of electron. If you connect this, you will get one shape. That is the shape of that molecule. Why they are moving in these directions only means we cannot say, because if they move in those directions, then they experience the minimum repulsions. So that is what it is here, concept of VSEPRT. And another one is there here, whenever lone pair of electrons are there, means lone pair of electrons. Lone pair of electrons are there, where they are present? They are present where? They are present on the central atom. Clear? But bond pair electrons are present between the surrounding atom and the central atom, somewhere here. But lone pair of electrons always near to what it is, central atom. So that's why lone pair electrons occupies more space compared to the bond pair electrons. If it is having more space, means in that space electrons will be present. So that's why they experience the more repulsions. Suppose just I will say, and here oxygen is there, hydrogen and hydrogen. Clear? So here two lone pair electrons are there. These two lone pair electrons, these are lone pair electrons, they occupies much space compared to the bond pair electron, because bond pair electrons is not near to the central atom. They are in between the central atom and the surrounding atom, somewhere here. They occupy, less space. Then what will happen? Here two electrons are there. They are electrons. They will roam here. Here they will roam. So they occupy more space. Means these lone pair and these lone pair will have very much repulsions. Because whenever this lone pair electrons coming, they will not fix it at one position there, because they have so much space. They revolve here and there. So they experience that means there is a chance. If they occupies more space, there is a chance to come close and experience the more repulsions. So that's why these lone pair repulsions, and it is bond pair here. Because this bond pair occupies the what it is here? Less space. Less space means minimum repulsion. So bond pair will have minimum repulsions, and lone pair will have maximum repulsions. And lone pair will have means less repulsions compared to lone pair and bond pair. Clear? Lone pair bond pairs will have less repulsions compared to lone pair and lone pair. Where the more repulsions we will observe, lone pair, then lone pair, then bond pair and bond pair. So this is about the what it is here and the main postulates of valence shell electron pair theory. Now I will write the points one by one. So you just know. So I have already explained. So the theory of valence shell electron pair repulsion. Clear? So I have written here points. So what I have explained and those points only. Clear? See that as first I have mentioned, it was given by which one? Sedgwick and Powell and developed by and Nylon and Hellerstein. Clear? Next one. This is the first theory to explain the shape of the molecule. Clear? And these are the main postulates of VSEPR theory. Clear? So what is the first one? I already mentioned. The shape of the molecule depends upon the number of bond pair and lone pairs. If more the bond pairs and lone pairs, more will be the repulsions and they move away from each other in the space and occupy a definite position. Clear? So that's why the shape of the molecule depends upon the number of valence shell electrons. Valence shell electrons means what? Bond pairs and lone pairs. Suppose NS2, NP3 is there. So here 2 electrons are there and here how many electrons are there? 1, 2, 3. NH3 if I take ammonia 3 bond pair means these unpaired electrons only participate in the covalent bond formation. So it will form 3 bond pairs. Here 3 bond pairs and 1 lone pairs. Means these are valence shell. Means ammonia formation takes place and here this is a lone pair on the ammonia. One hydrogen will give 1 electron, another hydrogen will give another electron here. These are bond pairs and it is what it is lone pair like that. So that's why and it depends upon number of bond pairs and the number of what it is here lone pairs around the central atom. Clear? Next, this pair of electrons repel one each other. I already mentioned pair of bond pair electrons are there around the central atom. Bond pair electrons will be there and lone pair electron also there. And these are all electrons. Electron cloud will be there around the central atom. Electron cloud means what is the charge? Negative charge. All are same charges means same charges repel each other, you know. So that's why here second point, pair of electrons repel one another since their electron clouds are negatively charged. All are negative, so that's why repulsion. Clear what? These pair of electrons tend to due to these repulsions and means the molecule will have high energy. To minimize that energy, these pair of electrons tend to occupy such a position in a space that minimize the repulsions. Minimize the repulsion means minimize the energy and thus maximum distance from one another. To minimize that energy, so these pair of electrons, you know, they move away from each other and occupy definite space in the definite positions in the space. Clear? Why they are moving? To minimize the energy. Clear? They move maximum distance from one another. Now, the number of electron pair in a single bond, double bond or triple bond or daily bond counted as only one pair. Suppose I will write here there will be a double bond O here or here single bond O or single bond NOCl like it is there. Clear? Here this bond is there, single bond, but here which one is there? Double bond. Clear? But we will consider here one single pair of electron only. Why? Because you see here. So because what it is one? Because all the electron pairs in the same bond are oriented in the same direction only. If it is having 2 bond pairs here or 3 bond pairs, they are oriented in the same direction only. That is nitrogen and oxygen, it is in the same direction. So if it is 2 bonds are there, 3 bonds are there, doesn't matter. We will consider that one as a 1 bond pair only. That is only. Clear? Means what this concept here, it is comes in the hybridization. In the hybridization, and we will consider while hybridization only the single bond, not the bi-bonds, because the orientation, hybridization it gives, as we will discuss, hybridization gives the another concept, that is gives the shape of the molecule. And during the calculation of hybridization, we will not consider the pi electrons here, because and here 1 bond or 2 bonds or 3 bonds are there. Orientation of nitrogen and oxygen will not change. So that's why instead of 3 bond pairs considering, we will consider only 1 bond pair only. That is the third one. So the lone pair electron take up more space around the central atom than the bond pair. I already mentioned central atom is very close to the lone pair of electron is very close to the nuclei of central atom. Clear? But bond pair electrons, these are shared by the central atom and the surrounding atom. They are moved away from the central atom. So they are lone pair electron, it occupies more space compared to what it is here bond pair. That is only the concept. The repulsions between the electron pair and central atom is, I already mentioned lone pair is greater than lone pair, bond pair is greater than bond pair. Why? Because the lone pairs occupy more space. More space means the probability of electron density is more. It means more space means these electrons can move, and more space is available, so electrons can move here and there. So if another one lone pair of electron is there, so there is a chance, most probability is there to come close if occupies the more space, and there will be more repulsions. So more repulsions means this is the lone pair will have more repulsions than the lone pair, bond pair and bond pair and bond pair. So these are the main postulates of VASEPR theory. Clear? And now we will discuss here shape of the molecule. Clear? Shape of the molecule, or you can simply say geometry of the molecule with lone pairs and without lone pair. If lone pair present, then automatically it changes the regular geometry of the molecule or symmetry of the molecule. First we will discuss the geometry of the molecule without any lone pairs, only bond pairs, and after them and with lone pairs. What I will give at last after writing this table's final table, I will give from this table you will get in the competitive examination minimum 2 to 3 questions. That much important tables. Clear here? What I am going to write here. Clear? So here geometry of the molecules in which central atom not having any lone pair. It means what it is not lone pair electrons. Only what it is not bond pairs. Bond pairs means you already know. Suppose this is the central atom. This is surrounding atom. These we will call as a bond pairs. The pair which is involved in the formation of bond. This one bond means how many electrons? 2 electrons. That we will call as a pair. How many bond pair electrons are there? 1, 2, 3. Pair means 3. These are bond pairs. And here electrons we will write, this we will call as a lone pairs. This pair, the pair which is not involved in the bond formation is called as a non-bond pair electrons, are simply called as a lone pairs, that I have already discussed. Clear? So another one is clarification I have written. Clear? Number of electron pairs. Electron pairs means here only bond pairs only. Number of electron pairs means here 2 bond pairs are there. 2 bond pairs I will write here how they arrange. If it is a central atom, then these bond pair electrons are arranged in this way. Means why they arrange in this way? If they arrange in this way, they will repel. Means repulsions will be very minimum. So then the molecule will be most stable. So that's why these bond pair electrons are arranged occupy the undefined position like this. Then repulsions will be minimum. Then energy will be minimum. So what will be the bond angle here? The bond angle is 180. Clear? If I write here, what is the shape here means linear. What it is this one? Linear. So, and instead of I am writing just pairs here, I will write molecule. Means A, and here what is there? B, and here what is there? B. How many bond pairs are there? 2 bonds means 2 bond pairs. What will be the angle here? 180. What is the shape here? Linear. So this is only I have written the molecule, form of molecule. Example is BeCl2, HgCl2, or you can take as an example. Clear? No? So this is about the bond pair. How many bond pairs are there here? 2 bond pairs. Clear? No? Next one. If 3 bond pairs, how they arrange it around the central atom? Clear? No? So if I take this is the central atom, they arrange it in this way. This is one bond pair here, and here there will be one bond pair, and here there will be one. Why they arrange it in this way? If they are arranged in this way, means if they both occupy positions like this, then repulsions will be minimum. So clear one? So this is what it is not here, positions of bond. And if you write like this, if you add this position, I already said you will get the shape. Clear? No? So what is the shape means here? Trigonal planar. What it is here? Trigonal planar. If three bond pairs without lone pair, then that molecule will have the trigonal planar shape. Clear? No? So what is the bond angle here? You know this bond angle is 120 degree. Clear? No? So if I write the molecule here, so what it is A, and here there will be a B, and here there will be a B, and there will be a B. This is. Clear? No? So what is this shape here? Trigonal. Trigonal planar. Trigonal planar. Clear? No? What is the example? You can take boron trichloride, AlCl3, all can be taken as an example for this. Clear? No? So this is about what it is here. 3 bond pairs. Clear? No? So next one. If 4 bond pairs are there, how they arrange? If 4 bond pairs are there, this is the arrangement. Here. This is the arrangement. Clear? So if you connect this, you will get the tetrahedral shape. Which shape here? Tetrahedral. So you have to draw like this. This is tetrahedral shape. Clear? So means what is here? So in this one, what is the bond angle? If you take any angle here, bond angle here you can take here, or you can take here. So what is the angle here? 109 degree 28 minutes. So what is the shape here? Tetrahedral. Clear? So I will write here what is the shape. A with the molecules B, and here there will be a B, and here B, and here there is a B. This is tetrahedral shape. Clear? And you have to connect this and this. This is the actually tetrahedral shape. Clear? So this is what is the bond angle? You take any bond angle here. You can, means you don't think that here means angle is much and here is angle is less. No, it is actually 2 dimensions. So we cannot write exact shape. Here 109.28 degrees. Here also 109 degrees 28 minutes. Here also 109 degrees 28 minutes. Here also 109 degrees 28 minutes. What is the shape here? It is a tetrahedral shape. What is the molecule you can write here? CH4, SiH4, all these are RF4. You can write as a examples. So this is up to the 4. And now if I take 5, if I take 5, then what happens? 5 bond pair electrons are there, then what will be the shape? So if I take 5 bond pair electrons, so bond pair electrons are 5. Bond pair electrons are 5. Then what will be the shape? This is central atom. So this is lone pair, and this is another lone pair, and here lone pair, and then will be a lone pair here. This is a lone pair here. So this is what the shape here. Trigonal bipedal. What is the shape here? Trigonal. This is, you see, one triangle. This is a triangle. Trigonal. This is a pyramid line. This is a pyramid line. Trigonal bipedal. Okay? Again, you have to connect this, but if I connect all the bonds here, you will get confused. Simple. One is, triangle, and one pyramid and another pyramid. What we will call here? Trigonal bipedal. What is here? Trigonal bipedal. 2 pyramids are there. Trigonal bipedal. Clear? So here you see, this is a triangle. I will write here very clearly. So here B, and then we have B, and here there is a B. Clear? So simply I will write. First of all, I will draw the triangle here. Clear? So this is A, and here what is there? B, and here B, and here B. This is one triangle is there or not? One triangle, and this is another B, and here B. Clear? What is the shape of this molecule? Trigonal bipedal. trigonal biparallel. What is the angle here? You know triangle. Triangle means what is the angle here? 120 degree here. You see, it is separated by 120 degrees. But here, what is the angle? You see, this is a 90 degree. So here it is a 90 degree. So two angles we can observe here. 120 and another one is what it is here? 90. So that's why this is 120. This is what it is here? 120 degree, and this is how much? 90 degree. What is the example for this molecule? PCl5 we can take as an example. What is here? PCl5. So last one is there here. 6 electrons are there. 7 also I will discuss. Clear no? But 7 is rare. Clear no? So next one is 6 electrons are there. Pair of electrons how many? 6. If 6 electron pairs are there, then how they will arrange? So they arrange octahedrally. Clear no? So here there will be a pair of electrons. Clear no? So this is. Clear what it is here? Octahedral. Octahedral structure. Clear? If I write here, simply I will write this. A and here this is like switch. Clear? And here sample atoms B and B, B and B, and this is. So here B and B. If you see here in all cases, it is a square plan. It is a square first of all. Square means what is the angle? 90 degree. If you take here, angle is how much? 90 degree. Here also what is the angle here? You see one 90 degree. All angles are how much? 90 degrees. Okay. Clear no? Now connect this thing. This is octahedral. And from here to here. And from here to here. Opposite. From here to here. And here to here. So this is what it is now here. Octahedral structure. So what is the example is SL6. Clear? And last one is there. 7 electrons are there. What is now here? 7 electrons. Clear? So 7 electrons are there. Then what is only bond pairs? Clear? So here 7 electrons are there. It is a central atom. So here there will be a clear no? So here this is the how they will arrange. If they arrange bond pair of electrons like this, they will experience the minimum repulsions. And if I connect this, there is a one pentagonal, you see, this is 5-member ring, and here this is clear no? So what it is here, we can connect in this way also. So I am not connecting like this is, you see, simply how we will write. Clear no? So here central atom is there. This is B, B, and here bond, and here there will be a B and B and B. Clear no? So now this is also B. This is one. This is pentagonal biparallel, because this is one pyramid and here also one pyramid. So what it is now? Pentagonal biparallel. Pentagonal biparallel. What is the example means? I have said. Clear no? So these are about the geometry of the molecules with no lone pair electron on the central atom. If lone pair electrons comes, what is the shape? That also will be discussed. So here bond angles I have not written. See here if you take any bond angle in the pentagonal, this is a 72 degrees, and here what it is 90 degrees. This is 90 degrees. If you take this This is also how much? 90 degrees. So here, and in the pentagonal 72 degrees, and here bipyramidal it means you don't think that here it is not exactly 90 degrees. You don't think, because pentagonal is a planar. It is pentagonal, just assume. This is one pyramid and another pyramid is like this. This pyramid it makes this is a planar molecule. With any bond, this pyramid will make the 90 degree. Clear? So that is here. You don't think that. So here this bond is one is here and another one is like this. So it is not 90. Clear? It is 90 only. Why? Because it is a two-dimensional. You have to write the molecule. Suppose just if you take this is a pentagonal. Means here what is there one? And 5 bonds. This is a pentagonal. Just assume this is a pentagonal. And here pyramid and below pyramid. If you take any bond here, it make a which one? How much angle here? 90. That is. So that's why 72 and 90 is the. What is the shape of here? Pentagonal. Pentagonal by pyramid. So this is about the without orbits. Shapes of without orbits. So next one here, geometry of molecules in which central atom is having one or more lone pair of electrons. Previous without lone pair of electrons, now at least one or more lone pair of electrons. Then what will be the shape of the molecule? Clear? Geometry will be the same only, but shape of the molecule will differ. So what is that one? So here number of electron pairs. Just assume here 3 electron pairs are there. Clear? Means you don't think that here number of electron pairs means you don't consider here only the bond pairs. Clear? 3 pairs of electrons are there. In this one, 2 are the bond pairs and 1 is the lone pair. And how we will denote the type of molecule here? Central atom and bond pair of electrons. So sorry, right here bond pair and right here lone pair. Then it will be clear. Clear? How many bond pair of electrons are there here? 2. Means how many bonds will that central atom form? 2 bonds. So 2 bonds, and that one lone pair is there. That lone pair is represented by E. What is the type of molecule? AB2E. If suppose there is a lone pair, there is no lone pair, then how many bond pairs will be there here? 3. 3 means what is the type of here? AB3. Previous I should have write AB3, but I have not written, no problem. If only bond pair electrons are there, we will simply say AB3. If one lone pair electron is there, it is represent E. E means what is not? It represents the one lone pair of electrons. One lone pair of electrons. Then what will be the arrangement of molecule? Previous we have already discussed. First 3 are there directly. Then what I have written one? Central atom. And here there is one lone pair. And here I will write B. And here I will write B. What is the geometry here? Clear? What is the geometry here? Trigonal planar geometry. Clear? But what is the shape of molecule? If B is there here, and you will get the trigonal planar shape also. But here there is no B here. What is one? Lone pair is there. Due to that lone pair, and shape of this molecule changes. What is the shape of the molecule is? The shape of the molecule is bent shape. What is the shape of this molecule here? Bent shape. If one lone pair is there here, and the shape of the molecule should be, it will convert to trigonal planar. What is the bent shape? So what is the best example here? And the example is SO2 and O3. All these are examples. Clear? Next one. Next one is, suppose this is the first one. Next one is 4 electrons are there. Number of pair of electrons are 4. If you confuse, I will write this is simply what is here? Type of molecule I will write. Just you write here type of molecule. Clear? So here what is the type of molecule? AB2E. AB2E means how many electrons are there here? AB2 electrons means how many pair of electrons are there? 2 bond pairs, 1 lone pair. 2 bond pairs, 1 lone pair. And next one I will write here AB3E. AB3E. Total pair of electrons how many? 3 plus 1. 3 bond pairs, 1 lone pair. 3 bond pairs and how many? 1 lone pair. That is 3 bond pairs and 1 lone pair. Clear? So if it is no lone pair, only 4 bond pairs. You know tetrahedral structure. So right here A and one is here and this is B and this is also what is B. Clear ma? So here B. So what is the shape here actually? Tetragonal shape. Tetragonal geometry. Tetragonal geometry. So not tetrahedral geometry. So what is here? Tetrahedral geometry. Tetrahedral geometry. Clear? But because of one lone pair of electron and the geometry will be changed, that what it is here? Pyramidal shape. What is the shape of this molecule? Pyramidal shape. So you can write here the best example is ammonia. Ammonia will have which shape here? Pyramidal shape. Clear? And if in this case another one AB3E we have completed, and next one is we can write AB2E2. AB2E2 means what it is? Here two bond pairs and here two lone pairs. Two bond pairs and two lone pairs. Same here. You know, number of total pair of electrons are 4 means what should be the geometry? Tetrahedral geometry only. So here what I can write? A and here one lone pair and there will be a one lone pair and here what it is not B and here what it is not B. This is clear. What is the geometry here? Same tetrahedral geometry only. Because of this lone pair and the molecule will get the shape here. What is one here? Bent shape or angular shape. You can say. What is the shape here? Bent shape. Or you can say you know what is V shape or V shape. You can say angular shape also. What is the best example for this one is water. Clear? So water molecule you already know. So if you write here lone pair and here there will be a H and H. This is which shape here? Bent shape or V shape. Clear? So this is AB2E2. Clear? And the next one. If I write here 4 power and AB4E. AB4E. If it is only AB5 is there, all are bond pair of electrons, then you know trigonal bipyramidal is the shape. So but here what it is not? There are 4 bond pairs and 1 bond pair. Then what will be the shape here? And you know, and this is central atom and here there will be a one lone pair and the remaining I will write B and B and here there will be a B and here there will be a. So what is the shape of this molecule? You already know the shape of the molecule is trigonal bipyramidal. This is the geometry of the molecule. Clear? Geometry of the molecule. And if lone pairs are there, then what we will call this is a seesaw state. Seesaw. What is the seesaw? You know, and you know, kids will play the game, and there will be like this, and one will sit here, and another one will sit, and they will play. One will come down if it is more weighted person is there, and other side will go up. Clear? Like that. That is the like you see seesaw shape. Here, ground it will touch these two ground, and they will play here, A and B. Clear? So this is what it is, seesaw shape. Clear? So what is the best example for the seesaw shape is SF4 will So we have discussed bond pairs 4 and lone pair 1. Another one will be what? Bond pairs 3 and lone pairs 2. Bond pairs 3 and lone pairs how many? Lone pairs are 3. So then, so what we have to do? This is the shape of the molecule. Here, A will be their central atom, and here, and there will be a one lone pair, and here we put one lone pair, and clear? So then there will be a, this is A, this is B, clear? And this is B, and this is B. Clear? You see here, two lone pairs I kept here. Where in the triangle? Why we kept these two lone pairs in the triangle? Why not on the you know, in the pyramidal shape? Why we should not keep those lone pair? That we will discuss in the next class. Clear? So it is bond pair. So what is the shape of this molecule? Geometry of this molecule: trigonal bipyramidal. This is the geometry of this molecule, and due to this, you know what it is here? Lone pair of electrons, and the shape of this molecule is T-shape. What is the molecule shape here? T-shape. The best example is Cl for this molecule. Clear no? So this is about five pair of electrons are there. 5 electron pairs are there. In that one, 3 are the bond pairs and 2 are the lone pairs. And the next one we will take AB5E. Means what is how many bond pairs? 5 bond pairs, 1 lone pair. Octahedral structure, clear no? So we have already discussed the structure is what is one octahedral structure. So here what will happen? A and I will write here B and here B and B. This is the B and here I will keep 1 and here there will be 1 more. Clear no? So what is the actual structure here? The geometry of the molecule is octahedral. Clear no? Arrangement is what is here? Octahedral. But shape when it comes, you will get the square pyramidal. Square pyramidal. Clear no? This is what it is, square pyramidal. The best example for this one is BRF5. What is here? BRF5 is the best example for this one. So I will discuss why this is the square pyramidal will come. Why angles, how much angle changes when the lone pair is introduced into the shape of the molecule. Clear? That we will discuss in the next class. So next one is AB4E2. AB4E2 means how many bond pairs? 4 bond pairs and 2 lone pairs. And here also what is the arrangement of these electrons? Arrangement of these electrons are, you know, what it is here? Octahedral only. But here there are 2 lone pair of electrons. Clear? So what is the shape here? Here also the arrangement of this is octahedral. But what is the exact shape of this molecule is square planar. What is here? Square planar. The example here is Xe. So this is the what is here? These are the shapes of the molecule when lone pair of electrons present on the central atom. Clear? So next I will give one table very clearly, means how many, if total pair of electrons are 3 and if there is no lone pair, with the lone pair what is the structure I will give in the next class. And that table is very important for your PU as well as the competitive. Competitive very important because mostly 2 to 3 questions will ask from the table. What I am going to give the table in the next class. Clear? So just you practice, you will get it. Clear?